All right, so we're looking at dividing polynomials today. This is chapter 4.3. So hopefully you've had a chance to kind of look at your bell ringer. I'll get you your answers here for that, and we'll get rolling with the lesson, okay? So starting out, we're simplifying these. So remember when I taught these, we're looking at doing these two first, and then whatever we get out of there, we take it times that 4b to the negative third. You could do all three at once, but we did two at a time just to make it a little bit easier. So 3 goes in front. A's, we add the exponents, so a to the fifth, b to the fifth. Okay, and now we take that times that and finish it out. So 3 times 4, that's a 12. A to the fifth, and we add our exponents here, so that's b squared. So that is our monomial that we get when we multiply things out. All right, so we got some binomial expansion for the next one, all right? And I know we did this vertically when we learned it, so I'm going to try to do that for you over here. We get rid of this stuff. All right, so we got p plus 1 to the fifth. So remember, we take that first term to that power when we start out. So p to the fifth. Okay, and if there's a number in front, we should be using parentheses. Next number or term, p to the fourth, and that's where 1 comes in next. So p to the fourth, 1 to the first. Now, you might not want to write that out because that's just the 1, and it's going to kind of maintain as the 1 the whole way through, but I'll just do it for the purpose of the pattern. So we got p to the third, 1 squared, p to the second, 1 to the third, p to the first, 1 to the fourth, and then p to the 0, which is gone. Okay, 1 to the fifth. Let's get rid of this here so we don't have the 1 there. Okay. So then we came back in and we put our Pascal's triangles numbers in there. So fifth power, you go to n equals 5 in your triangle. So that's 1, 5, 10, 10, 5, and a 1. And then we looked at just multiplying each one of these out, and that's how we finished with our answer. Okay? So 1p to the fifth, that's just p to the fifth, plus, so 5p to the fourth times 1 to the first. So remember, these 1s aren't really going to make much of a difference. Okay, so we just really get 5, 10, 10, 5, 1. Okay, so 5p to the fourth plus 10p to the third plus 10p squared plus 5p plus, right here, there is no variable, so it's just a 1. So that is your expansion. Okay, it's kind of nice when there's just a 1. When we have another number with that, like a 2p or a 5 there, the numbers get a little bit bigger. Okay? So, this one, I didn't get the chance to teach you this in class, so we're going to kind of look at it, and we want to use the binomial expansion theorem, all right, because that's the easiest way to get this. Otherwise, you're going to be doing something like this where you expand the whole thing out, and then you're looking for that specific term. So we want the fifth term, okay? So I'm going to show you how to set it up with the binomial expansion theorem. So since it's 8th power, should be 8 choose 0 is the first term, a to the 8th, and b to the 0. Okay, that's a 0. We usually don't write the 0 out. And I told you all yesterday we don't write that out because that's just a 1. But for the purpose of understanding how to do this, I'm writing this out. Okay, so 8 choose 0 would be the first term, right? If we want the fifth term, kind of think about that. First term is a 0, fifth term should be a 4. So our combination should be 8 choose 4. So whatever number this is looking for, you're going to think n minus 1. You do 1 less. So if this is the fifth term, my combination should be a 8 choose 4. It should be a 1 less. Okay? Then let's make a correlation between these exponents and these numbers. Okay, this number is always going to be matching that number. All right, so this always matches that. Okay, so let's do that. So we're going to have a to some power, b to some power. And if I say 4 is going to be matching that, that is fourth power. Okay, now we have to remember when we're looking at the patterns here, how do I know what this exponent is going to be? What's the degree of the binomial? What's the degree of my expansion? So if it's supposed to be an 8, this would have to be a 4, okay, because 4 plus 4 is 8. Or, here's one more way to think about it. That back number goes up there. I subtract those two. I got my front number there. Okay? So 8 choose 4. We're going to use our calculator for that. So when I put 8 choose 4 in my calculator, so 8 NCR 4, you get 70. So this turns into a 70, and then we have a to the fourth, b to the fourth. Okay, so if you need to replay that to see that again, go ahead and do that at some point. This number matches that one. I subtract the 8 and the 4 or whatever the NCR is, and I get that front term because these have to add to that. Okay, so that would be how I find the fifth term of this expansion. Always think one less in your combination and then follow the patterns. All right, so onward and upward to the new stuff. So we are looking at division here. Okay, so simplest version of division would be dividing by a monomial. All right, we've actually done stuff like this before. If you think about dividing something like that, simplifying mx plus b type scenarios, we got to take the 2 out of both of those. So this would just be an x plus 2 if I simplified that, okay? Because I split it apart. You've heard me say that in multiple lessons before. So with this one, I have 3 things on top. That would be a trinomial, okay, divided by a monomial. We divide it out of all of them, okay? So you can think about it like this, where you write them all over that term, okay? And let's get those written out. So 5ab plus 10a cubed b to the fourth over 5ab. And now we just simplify each one of these, okay? Write that monomial under each one of those, simplify them out, and write what we have left. So the 5's are going to go away here. The b's are going to go away. So a squared over a, that is just an a. Okay? 15 over 5, that would be a 3. A's are going to go away. And then we subtract from the bigger exponent, so that would be a b squared. Okay? Last one, that's a plus. Doesn't look the best. We'll go with it. 10 over 5, that would be a 2. Take out an a, so that's a squared. Take out a b. That's b to the third. Okay, so that's what we got. So dividing by a monomial, you split it up. All right, so if you want to go ahead and pause the video, try this one, and I'll come back with the answer. All right, so dividing it out of each one of them, I'm just going to kind of look from one to the other rather than writing them all out because that's the more efficient way. So here to here, same exact thing, that's a 1. Here to here, 6 over 3, so that's a plus 2. Take 2 x's out, x to the third, take one of the y's out, we just get a y. Back here, minus, take out that, 9 over 3, that's a 3. Take out 2 x's, that's x to the fifth. Take out 1 y, that's y squared. And that's what we got. So division with the monomial, not too bad. Okay, you can kind of do some mental math here, divide that out of each. Just simplify things down. Okay? So before we get into the long division with the polynomials, we got to remember how to do long division with regular numbers. Okay? So if you want to pause the video again and try this one first to see what you remember, you can do that. Okay? Because a lot of us probably haven't done something like this since maybe 3rd or 4th grade. Because as soon as we get to middle school, we start loving those calculators quite a bit. So this is where we got to understand how to do something like that. So when you first did it, we go 7, so this is 125 divided by 7. We looked at the first digit. Does 7 go into 1? No. So you either wrote a 0 or you might have written an x. Okay? Then we look at the 2 digits together. Does 7 go into 12? Yeah, it goes in there 1 time. So then we take out 1 7. So 1 times 7 is just a 7. And we're taking it out of the 12. So 12 minus 7, that's a 5. And then we drop down our next term and continue the process. So how many times does 7 go into 55? Well, if we think of our times tables, we got 7 times 7 is 49, so that's a 7 up there. Okay, so we take the 7 times the 7, like I just said, that's a 49. Subtract it out, left with a 6. Okay, and then when we first started doing it, we said, okay, remainder 6. That was when we first started doing long division because we didn't know a whole lot about decimals or fractions, okay? When we learned that, then we kind of forgot about the remainder 6 thing and gave ourselves a handy-dandy little decimal and a 0. And then put a decimal up here and continue the process. So put the 0 there. How many times does 7 go into 60? 7 goes into 56, right? That's 8 times. So we're taking out a 56. And then that leaves us with a 4. So we're subtracting these every time. We're just doing times tables and subtracting, okay? And then 7 does not nicely go into 4, so we'd put another 0, continue the process. So 7 goes into 40 5 times. That's taken out a 35. And you get the idea. You keep going until either all the decimals are done or you figure it out that it just keeps going on forever, okay? Which this one should stop at some point, but you get the general idea. So we're stuck at 17.85. Okay, we're going to kind of latch on to the remainder idea. All right, so another way that we did that remainder when we started learning mixed numbers. Okay, so let's get rid of all this stuff. We learned mixed numbers and we were here. Okay, so let's just leave it like this. That 6 was there. So we said, all right, 17 remainder 6. Well, we learned mixed numbers, and we said, well, there's 6 out of 7 left. So we said 17 and 6/7. That's how we do it with a mixed number. That's kind of the idea we want to latch onto today. All right, so let's see how it works. We're looking at something like this with long division. So the big one, obviously this is our larger one, is going to go in the long division bracket, and this will go outside. Now, notice, standard form should be important here. So 4th power, 3rd power, 1st power. What are we missing? We are missing an x squared. Okay? So you give yourself a placeholder of 0x squared when we write this stuff out. That's going to help us keep things organized. All right? So let's write it under our divisor sign. So 3x to the 4th minus 5x to the 3rd plus 0x squared. We have to have every single term for standard form in this one and this one. This one's good. Okay, 0x squared plus 4x minus 6. Write this guy out front. X squared minus 3x plus 5. And we're ready to roll. Okay, so the process with this, all right, we want to figure out how many times x squared goes into 3x to the 4th, okay? You can think about it, figure out the number, but what I recommend, so you don't have to think about it a whole lot, I want to divide this by this. So always divide the front two terms. So 3x to the 4th over x squared, that is 3x squared. So that is how many times x squared goes into 3x to the 4th. So when we divide those front two terms, we figured out that first number, or first monomial, first term, okay? So now think about what I just did in the last one. I put that number up there. I multiplied by the 7 that was in front. I wrote that down below, and that's what I subtracted out. So now we have this term, and we have multiple things in front, multiple terms. So we have to multiply into each one of these to figure out what we're taking out, since we're dividing this polynomial by this polynomial. So that's where it starts to get a little more complicated. All right, so distribute this through after we figure out that term and write it up there. So 3x to the 4th minus 9x to the 3rd plus 15x squared. Okay, and this is what we're taking out. So we're subtracting this stuff out. So since I'm subtracting a group of things, we change all of the signs. Okay, and that's going to help us keep things straight. We have multiple things we have to subtract out. And when we do that, those first two terms cancel. That's the point of doing that. We're breaking this down. Okay, so now we can just kind of add like terms going down and do the process again. Okay, so we have a 4x to the 3rd and we have a negative 15x squared. Make sure you show those negatives somewhere, that way you don't make a mistake, plus 4x. Okay, and one more thing I want to reiterate here. See that 0x squared? Okay, if we didn't have that 0x squared, we wouldn't have anything line up with this negative 15x squared. So it's kind of nice organizational strategy when you're doing this. All right, so process repeats itself after we go through one round. We go through until this exponent is less than this exponent. Okay, then we can't go anymore. So same process. I look at this front term, I look at that front term. How many times can they go into each other? Well, let's divide it out over here. So 4x cubed over x squared is just 4x. That goes over here, positive 4x. It always needs a sign. And repeat the process with this. So 4x is going into these three terms now. Okay, so 4x times x squared, that's 4x to the third. They should match. That's the purpose. So minus 12x squared. Okay, that's that times that. And then 4x times 5. That's plus 20x. All right. Now that matches, so if we put those together, we'd have an 8x to the third. What did we say to do on the last one? Subtract. Change the signs. That's what we do in division. We subtract things out to break that number down. Now those cancel. All right. So we have a negative 3x squared, and we have a negative 16x. And then I can still keep going. I have another term up there. I got to drop it down and repeat the process one more time. So once we figure this stuff out, where I put that number up top, distribute it through, minus it out, that's the process you're just running through every single round until this exponent is less than my divisor. Okay? So divide our front two terms. We got negative 3x squared over x squared. That leaves us with a negative 3. So that's the number going up top. Same process as before. Drag it through here. Negative 3x squared plus 9x minus 15. And then again, what did we do here? Change those signs. We got to subtract it. Okay, then those are out of here. We got a negative 25x plus 21. Okay, so now this is x to the first power, which is less than x to the second power. So we're done. We can't divide any more out. Okay, so that's where we lean on the idea of our remainder. Okay, so we had a 6. We put 6 over 7. We're going to do the same kind of idea here. Okay, we're putting this binomial over our trinomial that we're dividing with. Okay, I always recommend to add the remainder, then you don't have to worry about the signs. We could put the negative here since this is a negative, but sometimes when there's a negative on the bottom, it kind of messes things up, and so we just kind of keep that negative with the remainder that we got left there. Okay, and that is our long division process. Okay, so divide the front two terms. I'll kind of give you a recap here. Divide the front two terms over here. Okay, then we figure out what goes up top. Once I figure that out, distribute it through, and then subtract it out. Add like terms, drop the next one down. Same process repeats. Divide the front two terms right there. Write my number up top. Distribute through. Subtract and add, subtract or add like terms. Okay, continue the process till you get to a remainder. All right. So let's give it a shot on another one here. So we got x cubed plus 5x squared minus 7x plus 2 divided by x minus 2. So x minus 2 outside the bracket. And then we have x to the third plus 5x squared minus 7x plus 2. Okay, what was our first step? Look at the front two terms, divide them out. X to the third over x. That's x squared. Okay, let me make a mention before I keep going here. Did we have this in standard form? X to the third, x to the second, x to the first, constant. Yeah, we were good to go. All right, so hopefully we saw that and thought about that first. So once we write that x squared up there, we are taking it through. Okay, x to the third minus 2x squared. All right, what do we need to do with this stuff when I write it down there? I'm not just going to put these together because that gets me a 2x to the third. We got to subtract. All right? So then those are gone. I get a 7x squared. And then we drop down the next thing. Do it again. So 7x squared over x, that's a 7x. All right, so plus 7x. Take that 7x through. 7x squared minus 14x. And change our signs. Do it again. So that is a 7x here. Conveniently got another 7x. Plus 2. Divide the front two terms. 7x over x. That leaves us with a 7. Okay? And put that 7 up there. Distribute it through. 7x minus 14. Change our signs. And 16 is the last number. So 16, there is no variable. Or you can say the power of the variable is 0, which is less than that. So our remainder is 16. And we write it over that x minus 2. Okay? So if you're working with a partner on this stuff, okay, when we try another one here, and you all get the same remainder, that means you did it correctly, okay? So you can kind of work through all the way, get everything done, and say, hey, did you get a remainder 16? Yes? If yes, then we got the right answer, okay? The remainders should match. Okay, let's try another one here before I show you synthetic division. Okay, so we have 2x to the fourth plus x third plus x minus 1 divided by x squared plus 2x minus 1. Go ahead and pause the video, give it a shot, come back for the answer. All right, so we're taking this divided by this. So our x squared goes in front. X squared plus 2x minus 1, and then our x to the fourth, 2x to the fourth, goes inside here, plus x to the third. What should come next? Well, we go 3 to 1, so we need a 0x squared plus x minus 1. And now we begin the process, okay? Divide those front two terms, and we get 2x squared. Write our 2x squared up top. Distribute. Okay, so if we got this process down, it's pretty much the same thing all the way through. So when we're doing this, okay, I'll write these down here. Minus 2x squared. When you're doing this and you feel really good about the process, okay, next thing you should do is start checking your signs, because sometimes we'll go through this. We know these are supposed to cancel, but then we don't change our signs at all right? So be careful that you make sure to change your signs. So those are out of here. We got negative 3x to the third plus 2x squared and plus x. We got to bring that x down there. And do it again. So negative 3x to the third over x squared. That gets me a negative 3x. Okay, so negative 3x there, drag it through. Negative 3x to the third minus 6x squared plus 3x. All right, don't forget what we got to do here. Change those signs. So those are out of here. 8x squared. We got a positive x minus 3x, so it's minus 2x. Drop the 1. And these match. That means we got to go one more time. So 8x squared over x squared. The magic number to finish out with is an 8. So let's put that plus 8 up there. Take it through. 8x squared plus 16x minus 8. That's a funky x. Let's fix that up. Okay. Distribute that negative. Change our signs. And then finish it out. So we got 18x, negative 18x, plus 7. Okay, let's double check everything. So I divide my front terms here, 2x squared, take that through, 2x to the fourth, plus 4x to the third, minus 2x squared. So it's kind of confusing when you check these because we flipped all the signs. You just have to think opposite of what you have here. Okay, so negative 3x to the third, plus 2x, drop the x down, do it again. All right, so we're dividing this by the x squared. You get a negative 3x. Okay, so that should be a 3, 6, 3. And I think we got it right. All right, so we got this, 18x plus 7. That's the remainder, negative 18x plus 7 on top of x squared minus, or excuse me, plus 2x minus 1. So that is long division. There are some that you're going to end up with some fractions here, okay? But if you follow this routine, take my front two terms and divide them out, I should see those fractions, and it shouldn't be that bad when I distribute them back through. All right? One more concept. Let's take care of synthetic division. All right? And this one of these here, if you see that, okay, this just means divide. That negative 1 means move it to the bottom. And then I write it in standard form. So I'd rather write it as negative a plus 2 and do this divided by this. Okay, quick little side note here. But we get to synthetic division. So synthetic division is a quicker way to do this, all right? But it only works when you have things that are first power binomials, okay? If you have second powers, there's another way to do it, but it takes more time, or you have to factor and do it, all right? So this is what we're dividing by. We have to look at this and ask ourselves, if this were a factor, what would be the 0? So we set it equal to 0, and we get x equals negative 3. All right, most of the time you can just say take the opposite of that number, but sometimes if there's a number here, we got to divide everything by it. So the setup looks a little bit different. I hope a lot of us have seen this before. So we have a little box up here in the corner, or some kind of a shape that separates that number from everything. And then we have a line like this. And our coefficients are going to go right next in line to our box. So 2, 1, negative 8, 5. Those are our coefficients from this polynomial. First term will drop down. So that 2 drops down. And then whatever's down here is going to multiply by our number in the box. So 2 times negative 3 is negative 6. And it goes in the next column there. Okay? Kind of has a matrixy type feel to it. So whenever we got numbers in here, always adding those. Add whenever we put a number here, add whenever we put a number here. So this is negative 5. Then we follow the same process. So I said whenever we put a number down here, we multiply those out. So 5 times 3, that is a 15. Add those together. Negative 8 plus 15, that is a 7. And continue the process. Negative 21. Add those together. We get a negative 16. Now this last number here, this is the remainder, okay? So if we did long division, we should get a remainder of negative 16. Now how do we figure out what the variables are going to be? Well, since we did an x to the third divided by an x to the first, we knock this guy down by 1. So that's an x squared, that's an x, that's a constant, that's the remainder. Remainder goes over divisor. Okay? To write it a little bit cleaner off to the side, we should have 2x squared minus 5x plus 7 plus, we'll just do, since I said use a plus negative 16 over x plus 3. That should be the answer. So if you double check this with long division, that's what you'd end up getting. Okay? So if you need to replay that again, go ahead and rewind a little bit and see the process. The process with the box and the numbers can be kind of confusing, but then once you figure it out, it's pretty easy. Okay? So we're going to try one more, and that'll conclude the video. All right? But remember, this needs to be in standard form before I start my division. So if I'm missing something, and let's just say that this is supposed to be a square, because we're missing that number. If I'm missing any variables or terms in here, I got to add zeros for them. Okay? So go ahead, pause the video, and give this one a shot. Okay? So now that we got everything set up, all right, so x plus 3 equals 0, we get x equals negative 3, just like the last one. Okay, however you want to put it in the box, some kind of a divide or a separator there, and then we have our coefficients. So 1 there, and then we have our 0x to the fourth and our 0x to the third. We're missing those, so those are my zeros here. And then our 4x squared, negative 1x, negative 1 constant. Okay? What did we do with the first one? That one just drops down. Okay, so whenever there's a number down there, what do we do with that number? Well, we take it times the number in the box, so that would be a -3, and then we added those. Okay, so then that means that should be a -3. Multiply again, that's a 9, so 0 plus 9 is a 9. Multiply this, -27. Remember, keep adding these here. We add these. So -27 plus 4, that's a -23. Multiply the -3 times the -23, that's a +69. So that gets us to 68. When we add those together, -3 times -68, that is a 204. That's a negative. Okay, so we put those together, we get a -205. Now we got to remember how to turn these back into variables and such. Okay, so we started with x to the 5th. We drop it down by 1. That's x to the 4th. This will be x to the 3rd plus 9x squared minus 23x plus 68 is the constant. -205 is the remainder. So I put a line like this on the last one. That just showed me that the last number is the remainder, or reminds me that the last number is the remainder. Okay? And again, if we write it a little bit cleaner, it should look something like this. Okay? So we have gone through long division and synthetic division. If you need to go back through anything, go back and restart the video and go back where you need to. Your assignment is listed in Canvas, and it is also here. Okay? So there are a few questions I want you to use synthetic division on. So the ones that are circled here in green, use synthetic division. The other ones, I think these are monomial division, and then this and this are going to be long division. 36 is kind of a challenge question. Your hint is to use factoring. All right? So hopefully you enjoyed the video and the explanation for long division and synthetic division. Thank you for watching.